Now we'll study radiation of heat. As just now we have discussed that the two phenomena of heat transfer, conduction and convection, we have just now discussed that these require material medium for flow of heat. In previous articles, we have studied that conduction takes place by continuous oscillations and collisions of medium particles, and convection takes place by physical transfer of medium particles. When we talk about the phenomena of radiation, we can state this by emission of electromagnetic waves from a body which can take place through empty space also. As we know that the electromagnetic wave doesn't require any medium of propagation, so flow of electromagnetic waves can exist in an empty space, so radiation can also take place through empty space. Regarding radiation, the very first discovery was done by Prevost, which was studied under Prevost theory, which is the basis of the whole phenomena of radiation. And just let us write down the basic statement of Prevost theory, which says every body in nature at temperature more than 0 Kelvin radiate electromagnetic radiations of several wavelengths to surrounding. These electromagnetic radiation which are having several wavelengths is called obviously polychromatic radiation, because single wavelength radiation we generally term as monochromatic radiation. So we can state this polychromatic radiation from the body is called thermal radiation. So we can state every body which is having temperature more than 0 Kelvin temperature, we can state it will always radiate electromagnetic radiation, which is a group of wavelengths, to the surrounding, and the energy lost due to these all radiations we call thermal radiations. We'll discuss the phenomena of this thermal radiation step by step in detail. As just now we have discussed in Prevost theory that if there is a body which is having temperature more than 0 Kelvin, it continuously radiates electromagnetic radiations to the surrounding. That means it is losing energy in form of electromagnetic waves. Say if we talk about its surrounding and which is having a temperature T, which is also more than 0 Kelvin, then obviously surrounding will also emit, which include the surrounding objects, atmospheric air and everything. So the surrounding will also emit electromagnetic radiations which will be absorbed by the body. So we can state that every instant body is losing radiations as well as absorbing radiations. So the radiation which it is losing can be taken as a total energy Q out, and the energy it is absorbing from the surrounding can be written as Q in. And we can say if Q out is equals to Q in, or the rate at which electromagnetic radiations is emitted or taking energy is equal to the amount of energy which is taken in by the body from the surrounding per unit time. If we are talking about the rate, the two rates are equal, then we can simply state the body temperature T will remain a constant, and we say the body is in thermal equilibrium with surrounding, because in this situation we can state, as the body is in thermal equilibrium with surrounding, in this situation we can directly state the temperature of surrounding as well as body are equal, so that the rate at which it is losing heat is equal to the rate at which it is absorbing heat. Say if body temperature is higher than surrounding, Q out will be more than Q in, so body will cool down. And if body temperature is lesser than surrounding, Q out will be less. And we can say with time, as Q in is more than Q out, the body temperature will be raised.